Hello, this is a continuation of the Chapter 4 Excel tutorial. Now, normally I don't do the thinking questions like these are, but I find students in particular that have been away from algebra for a while find these questions really tricky, so let's keep going. For part C, it says to use the regression equation to predict the head circumference of a child who is 25 inches tall. So they're giving you height and asking you for head circumference. That's a prime target for substitution if I ever heard it. All right, so let's see here. They said the child is how tall? 25 inches. So it's going to be equal to, now look at your formula, it's up here in bold, 0.183 times 25 plus 12.493. There you go. That many inches. Done. I'm substituting 25 in for height in this formula that we already created. All right, for part D, let's see what they want. Compute the residual based on the observed head circumference of the 25-year-old child in the table. All right, let me remind you what residual is. Residual is your error. It's a fancy name for error. It means how off is your line. It's the observed, oopsie, minus the predicted. Now, observed is what you see in the table. So let's go up here and see what the table says. There's the kid that has 25 inches for height. There's his head circumference, 16.9. And from that, we're going to subtract what we predicted would happen with our equation, which is what we just found right here, 17.068. Enter. There we go. That's the residual, so that's part D. I better bold these so that makes it obvious what they are. Those are the answers. Great. All right, let's go back. Found the residual. It was negative, by the way. I don't know if you noticed that. It's negative because we predicted higher than he actually was. In other words, this kid was below the line. If you were to go draw the line of least squares regression line on the graph over here, the kid at 25 is below where the line would be. See the line? All right, let's go back. Now what it says. Hey, it's like I planned it. Draw that regression line. Well, let me show you. You can kind of envision it, right? Right here, kind of, along those points. Well, if you right click on one of the points, you can choose to add trend line. See that right there? Add the trend line. Now it asks you what kind of line do you want to add? Well, we want a linear line. And if you want to, you can even display the equation on the chart or even display R squared on the chart. That's the correlation coefficient squared if you like. It's not going to hurt you. It's also known as the coefficient of determination in section 4.3. So let's do that and say close. And there it is. And now you're thinking, oh, this is kind of jumbling it up. Well, you can just click here and then look, move your cursor kind of to make that four-sided, almost like a compass arrow, and you can kind of move it around. You don't have to have it where they stick it. There you go. There's the line of best fit, and look at that kid at 25. He's below the line. That's why he's got a negative residual. He's well below. Up here is what we predict on the line, and down here is what we observe what he actually was. Alrighty. Part E is done. We drew that. All right. Notice that two children are 26.75 inches tall. One has a head circumference of that and one has a head circumference of that. How can this be? Well, that's rather obvious. Kids are different, right? So what they're talking about is these 2 points right here. How come they're on the same axis, x-axis there? Right? Well, it's because every kid's different. You can write that up. And then would it be reasonable to use the least squares regression line to predict? That's another thinking question, but let me give you a hint. The highest data value you have is up in the 27s, and the lowest you have is 24. 32 is well beyond what you know anything about. So I don't think that would be a very good move. And I think you would have to write up something over here to that effect. For parts F and G, you should write some answers in. But those are both thinking questions, so I'll leave those to you to ponder. Alrighty, we're done with 4.2. Next time I see you, it'll be for 4.3.